EIGRP Stub root. In this video, I am going to talk about a new feature about the EIGRP. We call it the EIGRP Stub root. This is one of the features that we should consider it when we are using EIGRP between our sites, between, for example, one main office and also one branch with multiple and redundant links. Let me first explain the EIGRP Stub feature. After that, we can talk about the configuration. It is so easy. Look at here. We have a main office. This is our main office, or maybe this is a data center of our company. And also here we have one branch. Okay. You know that in each company has multiple branch. One of the branches is, for example, this branch. And also let me to say that this is possible that you have, for example, 100 branches or 1,000 branches. It is okay. Okay. After that, as you know, we need to have connectivity to the branches all time. Okay. Because of that, in most cases, we are using redundant links or multiple links between the branch and also main office. Why? The reason is that if one of these links fail, the other links should be available for communication between the main office to the branches. Because of that, using redundant links, okay, is so popular in designing of the WAN. In the WAN, in most cases, for one branch, at least we are using two link, okay, and this link can be provided by the service providers or some other tools. Okay, this is our simple scenario. We have a main office, okay, include our servers, our resources, and also one branch, but you know that we have multiple branch with this same condition. After that, as you can see, we have multiple or redundant link. Okay, also inside of the main office, you know that we have some communication of data. Assume that here we have a server 1. This server 1 should replicate its data with the server 2. Here we have two servers with the same functionality. They should replicate their data. Because of that, here, as you can see, between the router 1 and router 2, we are using one link, okay, between the router 1 and router 2. Why? Because we don't want to send traffic of inside of the main office, inside of the data center from the WAN link. Okay, actually, you know that inside of the data center, we are using the more bandwidth links, for example, or with highest capability link. For example, here we have 10 gigabit per second or maybe 100 gigabit per second. But in the WAN, you know that we are using the links with lower bandwidth. Because of that, as you know, here, as you can see, now we have a link for direct communication inside the, for example, data center or main office. Also, the routing protocol that we are using for routing is the EIGRP. Let me to show you what is EIGRP doing in this scenario. For example, you know that the R3 should advertise its network to the router 1 and router 2. This is obvious. You have learned about the EIGRP function. Here we have one EIGRP update. Okay. In this EIGRP update, we are sending 10.300/24 with the metric parameters to the router 1. That's it. So easy. After that, you know that the router 3 should send again this information to the router 2. Okay, because of that, now both router 1 and router 2 can send traffic to the 10.300/24, means the for example branch network. Also with the EIGRP, because here we have EIGRP, we are sending the EIGRP updates from the R1 to the R2. For example, R1 is sending 10.100/24 to the R3, okay, and also the R2 should send its network to the R3. For example, here we have the 10.200/24. You know it, okay? Because of that, with EIGRP, now we can easily send the network's information between all routers. Now R3 has passed to the 10.100 and also 10.200, and also the R1 and R2 have the connectivity to the 10.300. Until now, we don't have any problem. This is a normal behavior. For example, assume that you have configured this network and this network is working correctly without any problem. But in this type of scenarios, that is normal or a standard scenarios that we have in our, for example, real networks, maybe you encounter with some problems. Let me to talk about one of the most important of the WAN problems when you are using the EIGRP as a routing protocol. You should know about it and you should solve it with the EIGRP stop route feature. Okay, what can be happen? Look at here. Assume that the link between the router 1 and router 2 fail. This is a common, that's in some cases one of the links fail, one of the interfaces fail, and because of that assume that now we don't have the link between the R1 and R2. Okay, what is happening? You know that R2 is sending 10.2.0.0 to the router 3, and because of that the router 3 should send this update also to the router 1, 10.2.0.0 to the router 1/24. Also R1 is sending 10.1.0.0/24 to the router 3, and router 3 also should send this information to the router 2, 10.1.0.0/24. Maybe you know that before the fail, okay, and this was happened that the 10.1.0.0/24 was sent to the router 3, and also router 3 sent to the router 2. But because this path, the path from the router 1 directly is better path, we didn't use the route from the router 3. But now the R2 doesn't have any path to the 10.1.0.0 except this path, the path from the router 3. And also the router 1 doesn't have any path to the 10.2.0.0/24 except the path from the router 3. This is the normal behavior of the EIGRP, and until now we didn't, for example, experience any uncommon behavior. Okay, but now if you in R1 receive the 10.2.0.0/24, okay, from the router 3, when a traffic receiving to the router 1 for forwarding to this network, this traffic can be passed and should be passed to the WAN. And you know that this is not appropriate. Why? Because if you send the LAN traffic over the WAN, okay, actually the WAN can be, for example, saturated. Why? Because you know that here we have the traffic, okay, with the amount of gigabit. Okay, but here in the WAN you have the traffic with the, for example, amount of megabit bandwidth with the amount of megabit per second. Actually, you will lose your LAN, and this is happening so easy. Assume that we are sending traffic to R1 forwarding traffic to R3, and then the traffic received to the R2. Okay, maybe in the, for example, simulator or emulator, this is happening, but you know that in real world, if you send about 1 gigabit per second over, if you try to send a 1 gigabit per second over 1 megabit per second link, this 1 megabit per second link saturated, and the result is that you will lose your communication between the branch and also the main office. All of the branch links may be, for example, completely full of the traffic and maybe convert to a saturated link, and you cannot use these links. Because of that, as you know, this can be happen. How we can prevent it? One of the best solution is the EIGRP stop. What is the meaning of the EIGRP stop? You will learn more than this about the EIGRP stop in this video, but for now let me to say that with EIGRP stop or with the stop route, okay, stop route, we can configure, okay, one router, okay, as a stop router. Let me talk about the stop router. What is the meaning of a stop router? It is better to say EIGRP stop router. Okay, EIGRP stop router means this means we have a router that this router does not advertise the learned routes to other routers. For example, when R1 receiving one update from the, when R3 receiving one update from the R1, it shouldn't send, okay, not send this update to the R2. You know that in the normal behavior of the EIGRP, when R1 sending information to router 3 should send it to the router 2. This is the normal behavior, a standard behavior. But when you are using the EIGRP stop in router 3, actually you should configure the router 3 as the stop router